Hi guys, just going to run through a few definitions regarding hypothesis testing. So firstly, null hypothesis, the assumption that nothing systematic is happening, and the notation is H0. So basically, this is the event where nothing is happening in the experiment. What we believe to be true or what we think will happen is not actually happening. Next up is the alternative hypothesis. This is the assumption that something systematic is happening, and its notation is HA. So this is what we predict. So if we have an experiment where we are testing that exercise lowers anxiety, our alternative hypothesis would be that exercise does basically lower anxiety, and our null hypothesis is that exercise doesn't lower anxiety. And we would have numbers and figures to actually quantify our hypotheses. I'm not sure about the plural of that. Next up is the p-value. So p-value is the probability of obtaining the observed outcome at least as extreme as the one we observed if H0 is true. So basically, if H0 is true, so if the null hypothesis is true and that nothing is happening, what is the likelihood that we got the results that we did get? So this is the notation for it, p brackets obs / H0, or P observed outcome if H0 is true. This is pretty important because if the probability is really, really low that we got these results with the null hypothesis being true, then it means something is basically happening in the experiment and our predictions are right and that we can come to a conclusion from the experiment. And we measure the p-value in regards to alpha. So an alpha is the symbol that indicates the level of significance. So it's basically drawing a line at what probabilities are significant or not. So if alpha was really big, like 0.5, 0.5, not 0.05, and the probability of the event happening, if it was less than 0.5, that's 1 in 2 times. So really, that doesn't give us much information about the results, does it? You know, if like basically for example, 1 in 2 times exercise is doesn't reduce anxiety, then we can't really take much from that. Like basically that the event where exercise didn't reduce anxiety, that happens once every 2 times, like it's just useless. I haven't explained that very well, but I'll keep pushing on. So we're going to do an example here. So alpha equals 0.05, p is less than alpha. So the when we would expect to see this observed outcome less than 5 out of 100 times if the null hypothesis is true. Yes. So basically, if nothing is actually happening in the experiment, and we have this outcome like p is like 0.01, that means basically that just means that 1 out of 100 times we got this event happens without pointing the cause to what we believe is making the action happen. Basically, that's very improbable that we could get this result if nothing was happening. So therefore something is happening, and that means we reject the null hypothesis and we can make a conclusion from the experiment. If p is greater than alpha though, that basically means the results aren't improbable enough to make any conclusion that something happened. So in that case, we keep the null hypothesis, and we can't say with conviction that a change occurred. I've explained that a little bit poorly. It'll come much clearer with an example. I got a bit
confused there with the p-values and alpha. Thanks.